Good morning. My name is John Powers. I'm the moderator of the first panel, and I am not an expert on life sciences. But I have a great panel here, so you can ask me any question you want, and I'll get you the answer. Boston Properties is a leader in life sciences, but not in New York. We are the largest landlord in Boston and Cambridge, and also the largest landlord in San Francisco. So as a company, we are the largest office cap with about $30 billion in the country. So we do have some experience with life science, and we know that this is ripe for New York and can come to New York. Nancy, that was a great presentation, but the question is, how does all that really happen here? We have few sites. We don't have any of the space, so 1.7 million, Mitch said. We have little of the space that we need to have to attract life sciences, and we all know that New York is a complicated place to do real estate deals. There's few sites. We have a very complicated approval process, and how does that all work? But nonetheless, things get done in New York, and we've seen over the last 20 years a huge transition in the makeup of from the fire sector to the TAMI sector, and now tech is large in the city and becoming larger and larger. So I think this will happen. I'm not sure how it happens. I'm not sure when it happens. And I hope to know a lot more about that at the end of today. So let me start off by asking one of our panelists who's been around a long time and has a lot of experience in Cambridge, which is one of the great centers right now for life sciences, as you know, how it happened there. And Steve Purpura, let me also congratulate you on your move to my alma mater, CBRE. Hope it all works out for you there. Steve's been around for 20 plus years in this, started his career at Trammell Crow, so real estate goes into his DNA. But he's had a lot of experience in life science. So Steve, tell us how it happened there and why it will come here.
Great. Thank you, John. Appreciate the introduction. We've got a slide. I don't know how we control the slides, but we've got a slide on the Cambridge timeline. My quick background, as John mentioned, 20 plus years in Cambridge. I always say rather be lucky than good. I ended up in the heart of a market that has exploded over the last 15 years in life science. It wasn't always the case in the early 2000s, coming off of Y2K, and the market directly was impacted by sort of the lack of anything that happened there. The Cambridge market was 30% vacant. Rents were bottoming out as one of the softest markets on the East Coast. The life science market was in its infancy. When you see the slide in a second, you'll see in the early, mid and late 80s, there was a few companies that you'd recognize the names that had grown up in Cambridge, Biogen, Genzyme, Genetics Institutes. In New York, you had an example of Regeneron. I think it was in the late 80s that started with some technology out of Columbia. In general, the life science market was so speculative, as Nancy mentioned, that the only investor in that sector was the federal government. So we used to track NIH funding. The NIH funding would get announced. It would be dedicated towards academia and towards healthcare. And so the life science research that happened, similarly in New York, happened around the hospitals and the institutions. Thank you. Great. Am I hitting the wrong green button? So the NIH funding happened around the institutions, and so the life science. There we go. Here's the timeline. So the research happened around around the healthcare institutions. And so the lab space was around the healthcare institutions. Think about the East Side Science Center and why that's where it is. In Boston, it was in Longwood Medical. The rents in Longwood Medical, in the 90s were significantly higher than they were in Cambridge. And space would come online, and the NIH funding would come in, and the space would be absorbed. As Nancy mentioned, technology has changed that discussion. The Human Genome Project, which started in 1990, kind of when it came out with its initial results around the sequencing of the human genome, that changed the entire discussion. And so the way that we describe it is that it took, the idea of looking for a needle in a football stadium into looking for a needle within sort of a 10-yard spread. And then as technology evolved and virtual research evolved, in every sector, that research became much more viable. And so what came out of that was a market that was viable from private investment, was less dependent on NIH funding, was more sensitive to labor. And so in our market, when you think about sort of what happened and why, if you look at that timeline, the biggest sort of single moment that happened in the Cambridge market that changed everything was when Novartis relocated their worldwide R&D headquarters to Cambridge. In the early 2000s, it was a 200,000 square foot requirement. It came into town, and it was news. Fast forwarding to today, they have 2 million square feet of space. But more importantly, what happened was the cluster was created because the mentality around big pharma had been, up until that point, to do their research within their campus and to not collaborate in places like New Jersey and Pearl River, Switzerland. And the idea was, all right, well, we'll hire our scientists, we'll do our own research, we've got good data, we'll figure out our own innovation and go from there. No surprise, didn't work. And so once Novartis came into Cambridge, and said, this is what we're going to do. Then Pfizer came, and then Sanofi Aventis bought Genzyme, and the market was created. And that, to me, is the moment that we need in New York City, which we'll talk about in a second. The early stage companies that we have in Cambridge and Boston are designed intentionally to get in the way of big pharma. And so, like any other investment, the platforms and technology, it's not necessarily to sell the company, but it might be to sell a drug. It might be to partner up with one of the groups that's there. So the technology is basically designed and funded in such a way that they can get to speed to market very quickly, and the large pharma companies will come in. The market has grown significantly, which we'll see in a second, in Cambridge. So if you look at it from an overall market size, we're about 107 million square feet of lab and office space in Cambridge today. 10 years ago, we had about 11 million square feet of lab space. And today, we have about 18 million square feet of lab space. And in 10 years, I think we'll have 28 million square feet of lab space. The growth on average, really over the last 15 years, has been around 600,000 square feet per year. Over the last 10 years, it's been almost 700,000 square feet per year. So, it's a big number. It's not, obviously, we had, 2007 and 2008 was bad for us, too. The good years were better than that. But pretty significant growth that in aggregate adds up to a pretty significant amount of space. We'll get to it in a second. The biggest challenge with Boston is labor. It's not demand, right? And so this idea of open job recs, how do you fill up the benches? It's a very challenging environment for all aspects of these life science companies. And the real estate market is extremely tight, and the rents have gone up significantly. So the market has evolved to a point, sort of a tipping point a little bit, I would say. New York, you've heard the number 1.8 million square feet, over 472 million square feet. I mean, it's such a crazy difference between the markets and what's happened. We think that if you project a conservative amount of square footage on the growth side, which is 500,000 square feet, so if you think if Boston is 700,000 square feet, in New York, if we said 500,000 square feet a year, you roll that over 10 years, obviously you end up with 5 million square feet of growth in the market. I think that's a very realistic number. It is a daunting number to think about 500,000 square feet of new lab space coming online in a market that hasn't really seen that much growth. I will tell you that one of the things that I find interesting about New York is that to get to 500,000 square feet of growth in the life science sector, that's a lot of 10,000 square foot companies. It just is. It's a lot of 25,000 square foot companies. It's a lot of 50,000 square foot companies. The key, in my opinion, for the growth of New York life science is the Novartis moment for New York. Whoever that may be in New Jersey, maybe it's somebody in Europe, maybe it's somebody in Boston that comes into the market and says, this is a market where I can grow my company. So going back to my labor point, Boston, you can't find scientists, you can't find executives, you can't find folks to work in the companies. Very competitive, as competitive a labor environment as you can imagine. Come down to New York City, and for every 4.8 folks that have a life science degree that live in Manhattan or the boroughs, there's one job. So what does that mean? It means you've got an excess of labor here, It means that that labor is either working in other industries or is commuting out to New Jersey. I cannot tell you how many folks that I know in this industry that are commuting out, that live in Manhattan, that commute out to New Jersey, right? And so my opinion is the way to connect the dots is to connect the concept of the labor is here, the science is here, obviously the money is here, the institutions are here, and you've got the most creative real estate development community in the world, right? And so I think the idea around it is to pair up the concept of creating these incubator labs that are going to be the early stage companies, and then attracting, you know, a company that's in New Jersey that might have a presence somewhere else that is having a challenge on the labor side. And you think about, you know, sort of how you would do that and how accessible. As someone who commutes to New York every week, I can tell you this is a very accessible commute. You know, if you think about the idea of taking the train from Boston to New York, it's a 3.5-hour train ride, which you can be pretty functional on. And so the idea around in today's environment, moving forward for the next 10 years, where a company could say, all right, we're going to have a location for research in Boston and Cambridge. We're going to have a location for research in New York City. We're going to have a location for research in Philadelphia, maybe in D.C. And this whole Acela corridor idea would really unlock, I think, growth for the entire market. And you know, from a New York City perspective, when you think about what that could mean as an industry sector, I think the 500,000 square feet in the context of that conversation is really light. Seems like a very achievable number and seems like a very conservative estimate. And so that is, you know, sort of from my perspective coming in from out of the market is a little bit of what I think might be the key for the growth of the market.
Thanks, Steve. Let's move now to the city, and the city meaning economic development, New York City, and how the city is going to support the expansion of life sciences, why they want to support it, what their vision is, and specific things, steps that they'll take. So we have Doug Thiede here he's the leader from Economic Development and Life Sciences. So Doug, give us a little insight into New York City.
My name is Doug Thiede, lead the life science and healthcare team at EDC. Part of that team is leading the Life Sci NYC initiative, which Mayor de Blasio announced in December of 2016. That is the $500 million 10-year strategic plan of 10 different points, 10 different facets that Mitchell alluded to at the onset of our remarks. The reason we're doing that from a city's perspective is historically EDC has made targeted investments in different industry sectors. So if you think about New York City, some of our panelists, I think Nancy mentioned it really well, you think of it being a finance town, you think of it being a media town. More recently in the last 10 years, as Steve alluded to, you think of it as a technology town. We would like this to be a city known for life sciences, so New Yorkers have the ability to grow up and have jobs not only in our great academic institutions and the basic biomedical research labs, but also around commercial research and development and commercial pharmaceutical and biotechnology industry. Historically, New York City has had great institutions similar to Boston, as Steve mentioned. So we have 9 academic medical centers here that have a tremendous amount of NIH funding, second to Boston, and great researchers and investigators who continue to have that cutting edge science. But historically, we have not had those scientists be able to turn their science into companies here in New York City. And the predominant reasons for that have been either space or talent. We all know New York's expensive. This community knows that as well as anybody, but I'll kind of let the innovators in the real estate community talk to that a little bit later throughout the panel. But the space and talent issues have really been the catalyst for why this initiative exists and why we're excited about it from a city's perspective. So I'm going to talk a little bit. I won't go through the whole 10-point plan, but given that it's a real estate audience and there's a lot of expertise on that, I'm going to touch on some facets that are a little bit more relevant for that. So when we think of the 10-year plan, we think of it in 3 different buckets. One is connecting industry to the academic community. The second is unlocking space for companies to grow. And the third is building a talent pipeline for the future of New York City. On the left-hand side of the slides that don't exist, we've got about $150 million of city capital through 2 different programs that are designed to help with long-term strategic plans for New York City. One of those, I believe Mitchell alluded to in his opening remarks, of the life science hub concept. So this is up to $100 million of city capital and potentially city-owned sites to design a innovation district. We really want this to be kind of a Bell Labs of New York City. Many may not know that Bell Labs at one time was in New York City and one of the forefront innovators in the tech economy. We'd like to see something like that exist in New York City and have that be not just a building, but an area where some of those 10 to 15,000 companies could grow and expand not only in that building, but in the adjacent regions for that. We also want it to have that collaborative space that Nancy alluded to in her opening remarks. We don't want it to be just a building as it stands. So the second would be the research and development facilities, where we have recently launched a request for information to the community, where we're asking the nonprofit and scientific community to come up with what are the best ideas that will not only put New York on the map for today, but as Steve alluded to, of 500,000 square feet and additional space coming online, what are the scientific facilities and needs that will help with translational research of getting that lab science more towards products, medicines, and innovations that can stay in New York City. So companies would have access to it, research would have access to it. So this is a project that we've envisioned would be smaller grants of maybe $2 to $15 million. The call for proposals for that is in mid-July. For July 13th, I believe, is the cutoff date, where we will be requesting ideas and then assessing what the community says. What are those big scientific ideas of need that can help put New York on the map for more infrastructure? And really, through both of those, we don't want those proposals or those ideas to be about one entity. I think what Steve mentioned in some of his remarks were, you've got organic growth, you've got academic companies, and you've got large biotech and pharmaceutical companies that are in New York that make up some of those ingredients. So really, through those 2 proposals and the city capital, we want to encourage creative partnerships and creative responses to help build that community so it's not one specific entity. The second bucket that we think about is unlocking space for companies to grow, and there are a few programs that I'll talk to. So one, we're seeing that while these other 2 programs that I mentioned are very important, they're going to be long-term strategic plans that may take 5-10 years to come online. But what we're seeing now is that there is a shortage of space for those companies to go that may need that 10,000 square feet. So we've launched 2 concepts. One is our IDA tax abatement program, which is a discretionary benefit program of up to $300 million in real estate tax abatements that the city could control to help bring lab space and life science usage online. So this may be throughout all 5 boroughs of New York City. It's something that we've seen an extraordinary amount of activity from both the traditional real estate community in New York City that is now considering life science usage, as well as other entrants from different markets that have extensive lab and life science experience from other markets that are now considering New York for some of the statistics that Steve had mentioned earlier. The second program is a little bit more near term, of maybe helping some of those companies that need 5 or 10,000 square feet and don't have a place to go. And that's designed through expansion space funds, which is also a discretionary program that we've recently launched, where companies and developers can apply to EDC for either a loan or perhaps, depending on the stage of a company, for a convertible note to help with fit out of space. So if you were considering, for just example's sake, fit out of this space to go into more of lab usage, how could we help use EDC funds for fit out of that space, closing the gap between what a CEO of an emerging startup would be looking for and what the real estate developer is looking to cover the cost to get this life science ready. So those are a couple of the interventions that we've been focused on now. We've spent a lot of time with the broader community trying to figure out what are the near-term needs to help with those space challenges. The last component that I would say, and folks have alluded to it, are really the incubators. So we're very excited that for a long time, as you came out of the academic community, you didn't have a place to go as far as you had to stay in your lab space. Now with biolabs coming online later this year, J-Labs opening in the Genome Center next week, Launch Labs opened up last year in Alexandria Center. They're about 100,000 square feet for startups to grow. It's not quite at that 500,000 square feet that Steve alluded to, but we feel that there's a very good path there now, but we're trying to focus on where do those companies go next.
Thanks very much. Before we move on, let me just ask you to stand in. We don't have anyone from the state here, and I know you're not speaking for the state, but you're very aware of what the state's view of this is. So maybe you could comment on that.
Yeah, so within about a day of each other, I think, the state also launched a $650 million plan for the life science industry throughout New York State. It is something that we have worked very closely with our colleagues at Empire State Development. I think if you ask them, they might say a lot of our focus here is at EDC is more on these real estate-based initiatives. They're going to be looking at things not only within New York City, but throughout different areas. I think recently they've launched a project of called the Empire Development. It's EDI, the Empire Development Innovation Group, I believe, that is really trying to look at translational research through 4 upstate entities. Rochester and Buffalo, I think, are 2 of them, which is modeled off the Tri-I TDI program here through some of our institutions on the Upper East Side. They were also instrumental in the J-Labs project here, where I think $17 million of their 650 went to the J-Labs opening next month, which is about a 30,000 square foot incubator, which will come online.
Thanks very much. Next, we'll move to the question of finding space. And Bill Harvey logged some time in at EDC, and since then he's represented a number of tenants looking for space in the market. Bill, what are they looking for, and how do they go about their process?
John, thanks very much for having me on the panel. I really appreciate it. So it's very interesting. So I got started really, it was almost a fluke about 7 years ago. I just arrived at Newmark, and a colleague of mine from EDC had asked me if I'd be interested in helping her out with, I think at the time it was a 40,000 square foot project. That actually became the New York Genome Center, which when we signed the deal about 6 years ago was about 175,000 square feet. So it was my baptism by fire. It was a great way for me to learn the industry. I think that we evaluated well over 100 buildings. I think we toured probably 35 or 40 in 4 of the 5 boroughs. I think that the lessons that we learned there and then are still applicable today. Life science tenants like to cluster with other life science tenants, and I think that, as Steve alluded to before, I think it's really the institutions that are the pull. So we did a map. It's a little bit granular here, but it just kind of highlights some of the 9. I think we have a 10th actually institution, and I think that they tend to pull the interest in the geographies. I've kind of identified 4, maybe 5 different locations that we think are really primed for life science clustering, and I'll kind of start with the West Side. A couple of different submarkets within the West Side. It's to the north. It's the Manhattan Factory District. There's a lot of interest because of obviously Columbia University, but also CUNY. I would say that the one difference, I think clearly Kendall Square is an inspiration for what we want to do here, but I think it's not the inspiration. I think the one one difference that we have to kind of think about is the Manhattan, New York City, really public transportation system. It's so extensive. We actually, in a first draft of this, we actually tried to layer over the subway lines, and it just got a little bit too busy. So for those that are from outside the city and aren't as familiar with New York City, it's subway system. It's something that I'm happy to talk with you about after this. 619 West 54th Street. I saw Matt Weir from Taconic here. I think that Taconic has really planted the flag on the west side in the neighborhood that used to be Hell's Kitchen. I would say, thirdly, the area just north of us, Hudson Square into Tribeca. A couple of panelists have talked about it before, but the Genome Center itself at 101 A of A, which is also the site of J-Labs. I see Nicole McKnight from Biolabs. They're about 3 blocks away from there. That is the closest thing I think that we really have to a cluster right now, the Hudson Square area. The other two areas, just real quick, are the east side, kind of centered around the Alexandria Center. There's a lot of interest in that area. I think that Alexandria is the magnet, really, for life science in New York City right now. They obviously have the ability to do a third tower. Maybe we can get into that a little bit later. But 750,000 square feet of the 1 million square feet of private sector lab space is at Alexandria. There's a couple of development sites relatively close by. The area that I'm very bullish on is actually Long Island City. I think for those that aren't from New York, and even actually for some that are from New York, Long Island City is not on Long Island. It's actually 3 stops away from Grand Central on the 7 train. I think as we talk about clustering and as companies are making their decisions, you have to remember that these companies are competing for talent, and they're competing with talent with the Googles, the Facebooks of the world. Young, very well educated, very sophisticated, very urban kids, really. And I think that as we have kind of evolved as a potential life science market, a lot of the signs are actually pointing to Long Island City. I know that there was significant interest on the RFEI in Long Island City. I think it kind of starts with public transportation. There's about 8 different subway lines that run through what I would call well-located Long Island City. That is a challenge in certain other parts of the city. But I also think that Long Island City is kind of on the upswing right now. It's matured certainly as a residential market, but the life science market is primed for that area. I think I've heard actually Kate Merton speak about this before, but the airports. I don't want to steal her thunder because I know she's speaking later, but I've heard her speak very eloquently about some of the early success that the J-Lab has had in New York City, and I've heard her also talk about the airports, especially the international airports. That's actually something else that really bodes well for Long Island City. It is in the same borough as both JFK and LaGuardia. I think just to take a step back, and Nancy certainly touched on some of these things as well. What these companies are looking for is it's great space for sure, and I'll get into that in a second. But I think it's really a sense of community. It's the hotels, it's the restaurants, it's the proximity to housing. It's the bars, it's the health clubs, it's all of these things that employers are looking for because their potential employees really demand it. Just a quick, this is going to be difficult to read, but this is a building comparison matrix that we actually put together about 6 or 7 years ago. I've kind of tweaked it from time to time. This is actually a survey that we did for a client in late 2017. I think it's actually very interesting, but this is a tenant that's from outside of the 5 boroughs. This was actually the first tour that we did for them, and they only had about 2 hours, so we were very limited in terms of what we could show them. So we did take them to a couple of different markets purposefully. We took them to Long Island City, we took them to the West Side, and then we actually took them downtown. What I thought was very interesting was that this was a survey that was done in October, November of 2017. 2 of the 3 buildings were actually buildings that we evaluated 6 years before for the Genome Center. So it's a very small universe of properties. There's over 450 million square feet of space in New York City, but when it gets right down to it, there's actually there's a very small number of properties that are really primed for this. I think the threshold issue, and it certainly was for us with the Genome Center, is actually the landlord friendliness to doing something like this. I think a lot of people in the room here are developers, and they're thinking about an acquisition. That's a different story. It's very difficult to do kind of one-off leasing transactions in these buildings because the capital is the capital requirements are so great, and I think that that's a good thing. It used to be when I would go to life science real estate events that I would know most of the people, and it's actually very refreshing for me to see so many new faces here today. Just a quick look about the physical characteristics of the building, and I apologize because it's difficult to see, but we talk about floor loads. The bigger the better. We talk about ceiling heights. The higher the better. A threshold issue is also zoning. You really want to be in an M zone. I know that EDC, Doug, came out a couple of years ago with a memorandum that would suggest that commercially zoned buildings are okay for the most robust type of lab work. I don't think that that's really been tested yet. I'm a little bit out of my lane talking about zoning. I see Gus Mazza in the front row. He's really an expert on that. But I think it's a lot of things. It's the when I first got involved in the Genome Center, we all thought that this could be even a use that could go in a basement somewhere, and I could not have been more wrong. It's a tech tenant with a little bit of a twist. Obviously the wet labs, but I think that the same drivers that kind of went to create to turn Midtown South into the market that it is today are really kind of at play with life science as well.
Thanks, Bill. Before we move on to drilling down on the buildings, Steve, I'd like to go back to you. Bill put on the table Long Island City, Alexandria in the east, and the west. What's your choice and why?
Can I pick the 4th category of around Penn Station as a location that I like?
That's the west.
I feel like New Jersey is very important from a labor perspective. You can have all the scientists in the world, but you need the executives to run the companies. And I think if you talk to the VCs that invest in this sector, I think their big question mark and concern in New York City is lack of executive leadership for these type companies. Those clients of ours in Boston are on their 5th, 6th, 7th company that they run the actual companies. That labor pool lives in New Jersey, and so when we got to town, we were big proponents of the West Side. We continue to be big proponents of the West Side. And you think about the accessibility to New Jersey from Penn Station, I really am pretty bullish on the West Side and specifically in that area, from Penn Station sort of downtown.
Thank you. So you said the Jersey labor lives in New Jersey as well as works there, and that's a critical point in terms of developing life science companies.
Yes, yeah. I mean, I believe that as the life science labor pool moves to the suburbs as they get older, they move for the most part to New Jersey. They, a lot of them actually work in New Jersey while they're living in Manhattan, as I mentioned earlier. And if you look at the pharmaceutical companies that are in New Jersey, if you're in the sector, it's just a natural pull. And we've done the analytics for quite a few of our companies that are in Cambridge, that are in New York City. And once you get to a certain level, the pull south to New Jersey is very significant.
Okay, thank you. Let's move into the specifics of the buildings now. We have a slide up here, hard to read, but it shows different floor plates and different floor loads, different configurations. And we asked Steve Gifford, who's with Perkins Eastman, has been designing lab space and looking at buildings for a long time. Steve, give us a little insight into what we need for the buildings to function effectively for life science. We have a large building stock in New York, but they don't all have large floor loads, great floor plates, and ceiling heights are very challenging. So help us out and give us a little insight, Steve. Thanks.
So I get really excited about envisioning research space that really accelerates discovery. That's what it's all about. We need to create environments for researchers in old buildings or new buildings that help them collaborate, do their interdisciplinary work, and really accelerate, because everybody wants the discoveries faster and faster these days. So I'm going to talk a little bit about physical characteristics and also the spaces, not just the lab spaces, but I like to think a lot of discovery happens outside the lab, and it can really happen everywhere. So we need to create exciting, transparent spaces for researchers to get through their day and be successful. I'm not going to go through all these bullet points, but the lab trends include a tremendous need for flexibility, for plug and play. Gone are the days of solid walls and fixed casework. It's all movable casework. It's all transparency. It's all people seeing what others are doing and sharing their ideas. So the trend, if you go back a little bit, if you looked at a lab facility, it would be mostly open lab benches. But then equipment became so much more important. So these days, the equipment, the lab support spaces are equal in square footage to the open lab benches. The other thing that's really transformed laboratory environments is computational research. So you see in this chart, you see in the orange, the office space or technology space has increased. And that's going to continue to grow. Nancy referred to that. It's all about the relationship of wet research to computational research. But what's really happening now is the collaborative core. We're pushing the equipment. The equipment has to be convenient, but we really want the people in the center of activity, because that's where the ideas are and that's where the creations take place. So not going to go through all these statistics, but if you have a research group that's more heavily wet lab researchers, it's going to require more assignable square feet per researcher. Many research groups are hybrid, computational and wet, a little bit less square footage. And the dry researchers are really more like what you would design for office space, technology space. Bill talked about, I totally agree with him. There are some standards, some I've listed some minimums, but in science, the higher the floor loading, the better off you are. The higher the ceilings, the better off you are. Columns can be a problem. A grid that's modular at 10 feet is not quite enough. We're looking for at least multiples of 10 feet 6 because of the bench requirements and so forth. So life science facilities are very energy intensive. Designing them, we need to design with our engineers scalable systems because particularly small companies can't afford a lot of capital investment. But they are very energy intensive, and they've got to be carefully designed to be energy efficient, creating greater value for the tenants, the owners, et cetera. So this is a lab that was renovated at a hospital for special surgery. If I showed you a picture of the old lab, it would look like many incredibly old, incredibly opaque spaces that you've walked through. It does prove that we can create flexible, transparent space in older buildings. If we do have the luxury, I assume some of the market will be satisfied with new buildings as well as renovated buildings. New buildings obviously will, if you have the capital dollars to create the core and shell, will give you some more flexibility, some ideal floor-to-floors, and you know, good shaft locations. Everything can be exactly where it wants to be. We talked about technology. You're going to see, even in life sciences, more spaces like this at MIT. A tremendous amount of the work is done on computers these days. So the scientists don't spend all their time in the labs. They need other kinds of spaces. They need, during their day, they have long days. They need to contemplate. They need to collaborate. They need to innovate in imaginative spaces. And recharging, just like our cell phones, our days are long. We get a lot of information. We've got to get away from the action and recharge. You've got to create spaces like that for the scientists. Larger spaces are also required. Nancy referred to a community of researchers. Researchers want to be next to each other, even if they're competing companies. They want to be in a shared environment. So within the building, we create spaces that by day are for small collaboration, by night can become a forum space. The Kennedy School at Harvard is like one of the best examples of this. It's this incredible daily collaboration space for small groups, but at night, almost every evening, they have a presentation and an idea exchange. The younger generation is coming in. They socialize around food. Food is very important. So buildings need to have gathering spaces that are rich with food and social opportunities. And the lower right-hand corner is a space. I had the pleasure of working with the Mayo Clinic in Rochester, Minnesota. Now, they obviously don't have the advantages of New York. Their challenge is to create some of the things that already exist in New York. They needed to create a destination place, a place where venture capitalists, companies, and the Mayo clinicians can get together and work on projects together. It's going to be a tough challenge in Rochester. I think New York, I'm also very bullish on New York. New York has so many of the things already that Rochester wants to create for themselves. And really, you need to create an ecosystem. It's not just about the buildings the researchers work in. They want an exciting live, work, play, urban environment. And what city is better than that than New York? I'm not going to go through all this detail, but older buildings can be great in terms of transforming, but they've got to be transformative on the inside. They've got to be those transparent, flexible spaces on the inside, cool spaces for researchers. We analyze the different building components on the right. The structure of the building, if maintained, can last over 100 years. The skin of the building, 60 years or so until it needs to be repaired. Mechanical systems change over time, and they do need to be replaced about every 35, 40 years. And fit out, even if tenants are changing, the lab spaces should be designed so that not everything has to be rebuilt for new tenants. Thank you.
Steve, I have a question about New York and life sciences and the building stock here related to venting. This is the city of high rises, and I think that presents some challenge. Could you comment on that?
Sure, yeah. So, the venting idea.
Either Steve. Thank you. No, Steve, go ahead.
No, I've talked enough already.
Well, actually, New York has been very adaptive in that case. I remember the days when, like, Mitch Simpler and I used to go into the fire department, and we needed to convince them that ganging, they had, the old code required every individual lab to have a separate exhaust, which meant it was hard to create the extra venting capacity that you need in an urban environment. A bunch of us helped convince the fire department that that was sort of archaic thinking. So generally, we collect the exhaust at the top of the building into a plenum, and we rocket it at high velocities to make sure that, there are a lot of lab buildings in this city that are right next to residential apartments, and that's one of the ways we deal with the discharge.
And what's the height limit on doing that?
Height limit on
20 stories, 30, 40?
Yeah, that's an interesting. I would say 20. New York has also kind of created some of the tallest buildings, so there are chemical limitations as you go further up in the building. But I would say a 20-story lab building is very achievable.
I would just add that the size of the floor plate is important. So if you could get a 50,000 square foot floor plate, you can go taller. If it's a smaller floor plate, the whole idea around vertical penetrations as you get higher in the building, they just become, from an architectural perspective, a very limiting factor.
Okay, thank you. So, Matt Ashbaugh, you're with Hines, and you've taken over a very large portfolio in a prime area for life science, it would seem. It's on both Bill's list and Steve's very good list. There's a lot of space there, a lot of different existing buildings, and we know Trinity has a lot of other pads in that. All the developers in the room know that. We also know Norges has a lot of money, so that's a plus when looking at this. Tell us how life science would fit into the portfolio in Hudson Square.
Sure. So let me start just by explaining what the portfolio is and sort of how we had been managing it before we had life sciences on our radar. This is sort of just our evolving thinking as we're starting to pay attention to the sector. So Hines began managing the portfolio in 2016 along with our partners, Trinity Church and Norges Bank. It's 6 million square feet. 12 buildings in Hudson Square, so that's south of West Village, west of Soho, north of Tribeca. We comprise about 40% of that neighborhood. And so the strategy going in was basically to create a consistent management approach to the portfolio, rationalize the leasing across spaces. You have floor plates ranging from 30,000 square feet to about 80,000. And there are tons of examples of partial floor tenants or full floor tenants. And we're trying to sort of rationalize the leasing to create large blocks of space and appeal to mainly tech tenants. We did some demographic studies as we were getting interested in the portfolio and found that Hudson Square is actually the largest tech employee concentration in all of New York City, only second to Silicon Valley, and a lot of other New York submarkets are far down the list. And so that really appealed to us from an office leasing perspective. One of the levers that we've been trying to do just generally in the portfolio is improve the ground floor. So we've talked a bit about the appeal of live, work, play. We've got a whole retail leasing strategy to improve the ground floor experience and bring a lot of new food and beverage into the portfolio. So as we've been going about that, we've had a lot of success on the office leasing standpoint. But we've also taken note of what Doug's described as far as the city's support for life sciences and seen what Alexandria's been doing. And so it's just been pretty obvious to us that we need to get our arms around this space and understand sort of what it is that we're missing out on if we don't turn an eye toward life sciences. So this year we began a study effort, starting with meeting Nancy through Mitch. So engaged Nancy Kelly and Associates and JB&B and Hunter Roberts and Elkis Manfredi and Milrose and CBRE and Newmark, all to gather around our partnership and sort of advise on how should we think through the trade-offs between either stay the course, do office leasing, or think about conversion of a building at some point in the future, or buildings at some point in the future to allow life sciences. So the way we approached it, we basically started a study where we took an inventory of some basic building characteristics across the portfolio, came up with 4 candidates that we thought were good physical candidates for conversion. They all had 11.6 to 12.6 clear heights, 250-pound live loads, all sort of medium height buildings with fairly large floor plates, starting at about 30,000 square feet. And in many cases, they had latent elevator shafts that could be used for penetrations already going through the building that would allow shaft space. And so, but we also have a 10-year CapEx plan that's sort of slated for a very logical way to do CapEx for office use in the portfolio. So the question became, can we study buildings and figure out where the tipping point is where we might get comfort in changing to life sciences at some point in the future. So we started with 4 buildings. We decided to narrow it down to 1 building as far as a first study project. And we just approached that building very logically using Elkus Manfredi to design floor-by-floor test fits. We took sort of a progression of whether you would have an anchor tenant in the building or floor-by-floor leasing. We thought about an idealized world where you would have the tenants that have the most requirements for shaft space located higher up in the building, and ideally find a tenant that has lesser need for shaft space lower in the building. So that factors into some of the logic. JB&B helped us identify where we would run vertical penetrations through the building, in this case using 1 elevator shaft as the main means of vertical connectivity. And then we also thought about, there are trade-offs that you start going down where, like talking about venting, you need cannon fans to get rid of noxious fumes. And so those are somewhat noisy, they take up space. If you go down that path, you'd have to think about maybe closing the door in terms of improving the rooftop for potential use as just a tenant amenity later in the life of the building. And so we basically conducted that study and gathered the results. And the punchline is it makes a ton of sense to convert a building to life sciences if you can get the internal resolve to do the full thing. It's in the order of $70 million positive to our MPV over like a 10-year period. When we think about the costs involved, is about $130 a foot to convert the whole building, and then you get a chance to lease to attractive profile of life sciences tenants. On the other hand, it doesn't make as much sense to convert starting at around a floor or 2 floors. So really the judgment we're coming to is it makes a lot of sense to think about your go-forward leasing strategy and think about where you have blocks of space that may come to market. And if you're left with a lot to lease, it would be great to have another arrow in the quiver to appeal to life sciences tenants. And so we're sort of using that study as a starting point and still thinking about how we react to what the city's pursuing with the Life Sci initiative and thinking about just other tenants in the market that we're learning about through Newmark and CBRE and Nancy. And so I guess we're considering it as sort of an open door and an opportunity for continued study, but it's definitely one of those things where you want to do your homework building by building first to get the conclusions as far as how the building specs would align for leasing, and then think about whether you want to go there as far as a entire life sciences pitch, or if you want to have sort of a dual approach to still appeal to the office leasing market, but also turn toward life sciences.
Thanks very much. Could you share with us what you projected for rents and to make, I heard the good NPV, so that's always perks me up a little. Could you, the rents and also the TI package, and maybe one of the Steves or both of the Steves could comment on the how much it costs to build out lab space for the tenant?
Sure, absolutely. So as far as the tenant fit out, I'll start there. A lot of what we're finding is that it's really base building work required, and so it's around we're spending $44 million for a 350,000 square foot building, which is about $130 a foot for the base building conversion.
Rentable. Is that rentable?
Yes, that's rentable.
Gross,
Yeah,
rentable. Okay, thanks.
And so you start there, and that's really table stakes to even get out in the market and be able to offer a building with those types of specs. For the TI package, we've just keyed off of the Cambridge market, and we talked to Steve's team and Jonathan. It's on the order of it can go up to about $150 a foot, but a lot of tenants don't demand that. So there's a large range actually, and I think we certainly wouldn't want to start by offering that. But it's I would say office TI package plus to get started. But the interesting thing is once you have that type of a fit out, we've definitely been weighing the risks of the creditworthiness of life science tenants and especially growth companies. What happens if one blows out and you have to replace them? Often with an office fit out, and Steve, you could back me up here if you agree with this. You need it's basically a long consultative process to get to what fit out is perfect for an office use, and it's very, design driven, and it's got to match the exact branding of those types of companies. For lab use, it's really more about the specs required for them to conduct their job, and so if it's built to a Class A standard, that's not going to go away a decade from now, and so the conversion TI is way less than you would need to spend day one, and so that's part of the math that makes it attractive on a releasing scenario. Rents, I'd rather not comment on the dollars, but I'd say it's a 20 to 25% premium on face rates of what we think that office tenants are willing to pay, and that's really just driven by the profitability of these companies. So the ones that it's a good match where they are hungry for several floors of space. They're probably infused with enough capital to make it not as much about the cost of rent, and it's more about, are they occupying a good dot on the map that's perfect for their employees and part of a good building that allows them to do their work. And so we think there's more willingness to pay for the right companies that you're able to find.
Thanks. So my calculator says that's about 110 a foot.
We would take that.
But Steve Purpura and Bill, could you comment on rents and what rents tenants are prepared to pay? We have developers here, and we're looking to fill out our pro formas.
Sure, yeah. So it's funny because when you get to the point in the presentation where people want to look at comps, there's just not a lot to look at, and so it's a little theoretical. I will tell you that in Cambridge, the upper end of the rents that we're seeing now are year one rents in the in the mid 90s net, with annual bumps that are 2.5% to 3% on a 15-year deal. So you get out in a term, the rents are pretty significant, especially in the backdrop of what a Boston office rent would be. New York's a little uncharted as we get through it, and we're trying to figure it all out. I think that it's safe to say that a larger user probably will have a higher percentage of office, so spend a little bit less on their space, but they could spend upward of $250 to $300 a foot, including the allowance. I think it's safe to underwrite rents, pretty solidly, in the upper 70s net, and well-located product in Manhattan. I would just add the one other comment on sort of where it's going to happen. I actually think it's going to happen in all the different areas for a variety of different reasons. I think there's a place for another building with Alexandria for sure. There's and that rent will be significantly different than maybe something in Long Island City, but I think there's a place in Long Island City, and then up in Harlem, the same thing. I think it's safe to say that it's a significant premium off of what you would get from an office rent in the marketplace.
So I'd agree with that, both on the numbers and also the locations. I think again, if you look at the Boston example, there's Longwood, there's the Seaport, both in addition to Kendall Square. In terms of rent, I think it's actually somewhat surprising for a lot of New Yorkers. We're used to quoting on a gross basis. I think that the rents in Manhattan are 70. I mean, look at from a landlord perspective, it's as much as you can get. I think from a tenant's perspective, there is a threshold of pain. I think that the rents that we're hearing are $75, $80, $85 a square foot triple net. I think one of the advantages of going a little bit further afield, Manhattanville, Long Island City, is that you can be a little bit more competitive on price. But I think that one of the great perceptions of obstacle to life science real estate in New York City has historically been cost, and I think that the Boston example really disproves that.
Okay, thank you. We do have time for a couple of questions from the audience. We got a very good panel. I'm sure that there are things that you want to hear about. Do we have anyone? Yes.
Do regional and metropolitan rail transportation challenges factor into your plans? Do regional and metropolitan rail challenges factor into your plans to build a powerhouse life sciences industry in New York?
I would just say, and I'm always comparing everything to Boston. Compared to Boston, as Bill said, the transportation, for those of you that live in New York are frustrated. It's amazing. I was saying to somebody earlier, like, you never ride public transportation in Boston, and our traffic is just as bad as yours. And getting into Cambridge, and specifically East Cambridge, is one of the most difficult places to get into. I think the labor side of it and the accessibility of it will trump that. I mean, clearly, I always, say when I first got here, the idea of, life science and, everyone was pushing towards the outer ends of Brooklyn and sort of secondary locations that didn't have good public transportation, and it was a non-starter because, I think the life science companies are people too, and they live and they need to commute into the city as well. So I think obviously improved infrastructure would benefit, the life science idea, like any other sector.
I would just add that Steve talked about Penn Station, obviously Long Island Railroad, New Jersey Transit, Amtrak. I'll plug Grand Central for those coming down from Connecticut and Westchester. Grand Central, a great transportation node. And again, I don't want to be seen as shilling for Long Island City, but it's 3 stops away from Grand Central. So the tenant that I had alluded to was actually coming from the Connecticut area, and Long Island City was a site that they really liked because of the proximity for public transportation. If you also think about some of the expats that New York has seen, it's actually not only New Jersey, but if you think about the Regenerons, you think about the Accordas, they're actually north of the city as opposed to west.
One more question?
Let me add one thing on that
Sorry.
point.
Go ahead.
I think the other part that plays into our calculus is just why New York should show up on the radar as far as a growing life sciences market. I think in large part is due to the established presence of the universities and the healthcare systems. And so not just thinking about transit vis-a-vis a tenant and can you appeal to a certain company, but how are you relative to the other spots where those institutions could send people your way. So that's worked out very well for the Genome Center. And I think just having that awareness of how do you fit in the whole scheme, and because it is about the people and about not just one company, but the interconnectivity of people making their way to your space.
Yes.
Hi. I know you're talking to a lot of real estate people, but a little bit of this sounds like if you build it, will they come? And thinking about how we've done it, frankly, in the past, there were a couple of things that really made New York a tech hub. One was the fact that the people were here, and we just kind of brought an association together, and the bigger companies came because the smaller companies were here, and the innovation was here. What brought Novartis to Cambridge? Was it the fact that there was cheap rent, or there was real estate, or was it because there was institutions and there was an association, and not build it and they will come, but here it is and build it for them, I think, is a much greater.
Doug, do you want to start us on that?
I'll at least start. So I think that's something we hear at EDC a lot. I think one example that you can point to where it's worked is the Alexandria Center. You have 720,000 square feet where over the last 7 to 10 years, that model has worked. Bill alluded to that being one of the centers of gravity of life science in New York City. So I think you've got a mix there of academic institutions. Eli Lilly just expanded their R&D presence last November there. I think that says something, certainly in the market. And you've got growing companies, some of the VC-backed companies that Mitch referred to it in his opening remarks are based there as well. So it's not to say that that's if you build it, that will happen by any means. But I think one of the things we're seeing is other entrants, besides great organic growth, which is starting to come with a higher volume and higher quality, where you've got significant venture capital raises. You're also seeing large pharma and biotech companies pay more attention from a real estate perspective. Biolabs at NYU has done a great job landing large biotech and pharma corporate sponsors. Both Bristol Myers and Boehringer Ingelheim have a partnership with them. They're starting to pay attention to those early stage companies much more and have eyes on that without a physical real estate presence. J Lab's entering the market. I think that's certainly significant, and starting to see just other pharmaceutical companies, biotech companies pay attention. I think the fact that Pfizer is going to move from the east side to the west side, I think that, that certainly is a good thing. That area in Hudson Yards, there are additional pharma companies. So to the point that was brought up earlier, there are going to be a number of different clusters, and I think it's something that when you have Steve come up and talk about Boston with companies like Biogen and Genzyme, it's very easy for this audience to think that that can happen overnight, and it didn't in Boston. So we do want to encourage the organic growth and have a company like Regeneron have the opportunity to stay here, and some of that lab space and the buildings that we're talking about will give them those opportunities, but it may take some other entrants to come in and be a part of that physical space as well.
John, could I just add to that?
Sure.
I think historically, if you look at Boston and Cambridge and the demand that is created out of the co-working spaces, I think it's somewhere between 2 and 3x on an annual square footage basis. So we now have about 100,000 square feet of co-working spaces. Even if you shrink the multiple down to 1.5 or 2x, it implies a certain level of demand. And that's just from the co-working spaces. If we then start talking about companies that are outgrowing Alexandria, if we start talking about companies spinning out of the institutions themselves, and maybe even stealing someone from Boston or New Jersey, I think that there is a very healthy level of latent demand.
I like that.
You're talking about co-working spaces, which was the small guys, right? And the question, and what we had found is that, the small guys are the ones that attract the big guys, not the big guys bring in Novartis or something, and that'll attract small guys. Even Hudson Square was built on the co-working spaces and creating those small guys.
I would just say the medium guys are what I think you're missing. The medium guys are more important, and I'll give you an example. Semaphore is a company that incubated at Mount Sinai that's in Fairfield County now. When you look at the lack of space, the office space idea for tech is totally different, right? I mean, so a tech group can come in and take office space in this building or in any building, and so their ability to grow and scale is totally different. In a life science company, when you graduate and you get that $50 or $80 million round, you don't want to wait 18 months to move into your space. You're not willing to wait 18 months, and so you find a location that you can move in quicker. I think that if this market had developed a better infrastructure around the graduation space 2 or 3 years ago, I think that the market would be 4 or 5 million square feet. And so I think it's critically important that you address the real estate side of this equation, or you're going to continue to lose the Semaphores, who was a 100,000 square foot company, to Fairfield and to New Jersey and to these different locations.
I think biotechs not only want to be near academic medical centers, but need to be. I think the younger generation want it. They don't even want to own cars. They want to be in the city. So I totally agree. If we can collectively solve the real estate issue, there's a tremendous market. These companies and the scientists want to be in a city like New York.
Yeah, I would just add, whether it's the Semaphore example or others, we want to change that equation for certainly those companies to have those opportunities to stay here and grow here to be that mid-size and eventually larger company. What we're also seeing in instances like a Semaphore is they still have engineering talent here. And that's a very attractive part of New York City based on the last 10 years. You'll hear later in the panels today about bioinformatics and some of the other emerging technologies that intersect with this. And I think that's something that we're seeing a lot of these companies grow that might be more data scientist or tech-driven that intersect with a traditional life science or biotech company. And so that may be something you want to be considering for some of those space-based initiatives to attract some of those companies that are popping up throughout New York City.
Yes, growth is very important, and as you all can hear, there's a lot of complex issues here. Unfortunately, we're out of time, So thank you very much to the panelists. You did a great job.